that we saw yesterday. Praise the Lord. One of the maintenance guys came in and turned on my system so the heater is on. It was super cold when I got in this morning, but now it's working. If you guys get too warm, feel free to take off a jacket, etc. But careful, don't fall asleep. I got it nice and warm in here, but if you start falling asleep, well, we're going to have to get it cold again. So what was different than yesterday? My first step, or your first step, should have been to choose what? You. It's called U sub for a reason, to choose you. Wait, why? Well, that's not one of the basic rules, is it? Can I rewrite it to make it a basic rule? Can I get that y in there and then the nope, it's a U sub. Why? Because, do you guys see, it looks like it came from a composition of functions? Doesn't it kind of look like square root of u with extra stuff? Kind of? So u, what did you choose u to be? 1 plus 2y squared, because it was the innermost. It was stuck underneath a square root, and I agree. What do your steps say to do after choosing u? Find du, but how do you find du? Quick reminder, you could do u prime is equal to 4y. Then you could change u prime to be du dy is equal to 4y. Then you could go ahead and say du is equal to 4y dy. Ugh. But what else could you do? Do you think maybe we can get to the place where we jump right down there? Because isn't du just u prime times dy? Does that make sense? Looking in your notes yesterday really quickly at the ones that we did at the very end of class, didn't du end up being u prime times dx? Didn't du for the other one end up being u prime times dx? Do you see it? We're just saving time. We're just doing a shortcut in our steps. We could write out u prime equals 4y, and then u prime is du dy with differential notation, or dy dx. Sorry, du dx on the other page. And we could multiply, but let's just try jumping there. We're going to try jumping there for the majority of today. So you have your u, got it. You have your du, got it. What are you supposed to do with du? Do what? Yeah. Because what's the goal? What are we supposed to be doing over here? The next step says to... Okay, whoa, time out, time out. Where are you? Where are you? Where are your brains? Where are your mouths? Come on. What are you supposed to have open in front of you right now? Your homework spiral, but also your... having your notes open to. What did I tell you to be referencing? The steps yesterday we wrote for u sub. So, we already chose u, we already found du, that's steps 1 and step 2. And I might be off, let me know if I am, but I'm pretty sure we're on step 3. And so when I asked you what the next step was, you should have been able to say like, oh, it's right here. Okay, ready? Oh, it's right here, read it. What's step 3? Okay, so what are we supposed to do? Rewrite. How? Plug in. Plug in what? Who's you? Oh, that guy, that's right. Okay, so I have a u. Plug in what else? I don't have a du. Okay, so what are we supposed to do? Solve for dy. So what does dy equal? So that's what I meant by the next step. Because in order to get to step 3, in order to plug in, we're going to plug in the u where we found the u from, and we're going to always plug in for this differential. But to do that, we're going to actually, before we go plugging in, we're going to take du and always solve for the other differential, whether it's dx, dy, dt, d, I don't know. Now I have somebody to plug in. I can plug in du all over 4y. What else is here? A y. What happened? Well, what happens? The y's reduce. How'd you guys anti-derive? How'd you integrate? How did you, isn't that step 4? Solve? Anti-derive, take the integral. What'd you guys do? Okay, how'd you rewrite it? U to the half over 4. Ugh, I don't like that. Times 1/4. I think this is the easiest way to think about it. Stop, ponder. I don't want divided by 4 because there's no quotient rule. I would much rather have a coefficient. And a coefficient, how do I divide by 4? I multiply by a 4th. Are we okay? Okay. Now what? What do we do to the u to the 1/2? Did you guys end up with u to the 2 Sorry, 3/2 times 2/3, and you had that 1/4 just to chill in with the plus c at the end. Are we okay? Does it make sense, though? If you did get it wrong? We could do 2/12, or we could go ahead and reduce that to be 1/6. But what else am I going to do? Final step. Is it step 5? Replace the u. Who is the u? But don't forget, super easy to forget the power also. There's a lot going on. Are there different ways of writing it? Sure. But isn't that just the make and match step? So what was different in this example than in the 2 examples from yesterday? This one, we went to plug in. We went to plug in for dx. When we plugged in, what happened? This was a perfect u prime. Everything canceled out. How about this one? When we plugged in, the u prime perfectly fit. Everything canceled out except for the u's and the du's. But what happened here? When we plugged in, something canceled, but something remained. And we have to be careful about something remaining. So I want you guys to go ahead and go into your notes. I want you to write when u prime is off by a constant, and I actually want you to copy this example. Now, what would be a really good practice for some of you? You've tried it. I did it. This is one way of practicing math that you might not have thought of before, even though I've mentioned it or alluded to it a couple times. This is another way of practicing math. Some of you, it might be a great idea, because I'm asking you to copy this into your notes anyway, it might be a great idea to come back here to the very beginning and then start over and say, can I get there on my own? Once I've tried it, she's done it. It just is an extra level of making yourself practice. It's making you dig into the material just a little bit deeper. So homework spirals, we were back there because I wasn't exactly sure how it was going to go. I'm going to check with you guys in just a second and see how it went. But for right now, try to internalize this just a little bit deeper. Try to do the problem one more time. Following the steps, getting it into your notes, and also making yourself a note. U prime can sometimes be off by a constant. And more specifically, du can be off by a constant. Even though you guys had it in the back of your homework spirals and you could have double checked really fast, let's go ahead and see if you were able to once again get to the correct answer. And if you were, why don't you go ahead and move on to number 4. Let me see if I can zoom in, maybe. La 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 la. You guys should have gotten the problem written down by now. So you can double check the work and make sure that you got there. What I just had you do, just trying to have you internalize it a little bit deeper, a little bit more, make sure that you got it, is something that you could be doing anytime you get ready for a test. In that, if you have a problem where you're like, ooh, I don't know if I could do this again on my own. Maybe not doing it right away, but maybe doing it right away. Maybe giving yourselves a few minutes or a couple hours and then trying it again, not looking at the solution. Being like, I think I remember how to do it. It doesn't necessarily, isn't necessary for everyone, but it can be a way of internalizing it a little bit deeper. Because it's making your not just look at a solution and be like, it makes sense, but then given a blank problem, be like, but could you do it? And some of your brains remember things really well. Like your short-term memory is excellent. So you're like, well, it's too bad. Like it's in my head. I'll have it. Well, prove to me that you have it. And then give yourself a couple hours or give yourself a couple days and then try it again. Maybe studying shouldn't just happen the night before. But that's what I say when I tell you guys, if you're getting ready for a test and you know you're weak on something like a certain topic, to bring up the video of the class that we covered it. Go to an example and pause me at the beginning of the example and be like, okay, I did it once. I've read through my notes. I think I get this section. Can I do it on my own, by myself, right now, perfectly to the end? And once you try it, once you solve it on a whiteboard, on a piece of paper, in the back of your homework spiral, whatever, then playing the video and hearing me explain it, and you're watching your thought processes, you're watching how you solved it, and seeing if you got it right. What would have been a great place to do that for the last test that we just took? Motion. Because you were able to focus specifically on antiderivatives and motion. That's it for that part 1 on Friday's test. You know how many people were like, oh yeah, I bombed it. But why? You could have listened to me in class do motion examples with the special wording and talk through what the wording meant. You could have looked in your notes and been like, okay, this is the math that we did, closed it, gone to the video, paused it. At the beginning, we did multiple motion examples, and then we went over motion homework the next day. And you could have paused me before I ever gave any answers and been like, can I do it? And if you couldn't, you could have then played the video and like, what did I miss? Hit the ground. Oh, that means position has to equal. How fast? Ooh, I need to be plugging t into velocity. How high or how far? Ooh, that's a position. I need to somehow plug in a time to position. All of it was there at your disposal. But some of you need to learn how to study math. Because you've just gotten lazy, and part of it is because you never had to study math up until a certain fill-in-the-blank point. Just a few of you are like, no, I always had to study math. Good. Your study habits should be better than those that are just now struggling. Anyway, coming back. Any quick questions on this one before we leave it? What makes this one a little bit harder from the very beginning? But pause. What do you know about trig? Just looking at it. Secant tangent. Is that anything special? Yeah. You need to have your rules down. But if you look at this, I know there's a lot. There's a blah and a blah and a blah. And a, okay, but do you see the secant tangent? Is that helpful? Yes. Because do I know the integral of secant tangent? Yes. So let me show you what my brain is thinking. My brain is thinking, oh, I really hope, okay, there might be blah going on, but I really hope to get secant u, tangent u, du. There might be extra numbers or coefficients or hopefully not variables or I'm in trouble. But I'm really hoping to get here. Because I can say, oh yeah, that's secant u. Haha, plus c. So, what do you guys think we should choose u to be? What did you if you already tried it? Got it. And if u is 5x cubed, are we going to skip the mumbo jumbo and just go down to du equals? What's u prime? But what else do I need? Because the derivative of u is u prime. Another way of saying it, like dy dx is du dx. I'm just multiplying the dx on the other side. Why? Because because I need to get rid of dx. So what am I going to do with this expression? I'm going to start doing this in a systematic way. I apologize for messing it up there. But dx is equal to du over, okay, what's it time to do? Yep. So plug in. Where did you find the u? Inside the secant, so I'm going to put a u. Inside the tangent, I'm going to put a u, and then dx becomes du over 15x squared. What happens? Oh, I put cubed? Thank you. The x squareds reduce. What can I put in front? What allows me to take the 4 over 15 and move it all the way outside the integral? It's a constant. Isn't it the constant multiple rule? So I can say, oh, 4 over 15, it's constant. I can pull it out. Real quick, before you ever even come up against a problem that's going to tempt you to do otherwise. Okay? There's a temptation coming, and it's a really strong temptation, and you have to resist it. Ready? What if, just hypothetically, what if I had been right? And what if that was 4x cubed? How would that have posed a problem? Yeah, I wrote it wrong. Patricia was totally right. But what if I had been right? And what would I have been left with? Could I pull out a 4? Yeah, constant multiple. Could I pull out an over 15? Yeah, constant multiple. What couldn't I randomly just pull out of the integral? I can't pull out any variable expression. Are we tracking on that? Why am I warning you? Something like this is coming. And you're going to be like, I don't like it. I'm going to pull it out. Totally, completely, irrevocably illegal. Don't do it. Okay? Who's allowed to come out of an integral? Constants and constants alone. Are we tracking? Cool. So the 4 over 15 comes out. Did I finally get to my secant u tangent u? Ha-ha! And why is that amazing? Because the integral of secant u tangent u is secant. If you want, you can put secant u plus c, but somehow, step number 5, you have to get back to terms of x's. So how do I get back to terms of x's? Ask myself, who are you? Who is you? Who is you? Secant of 5x cubed plus c. Dun, 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 dun. How bad was this page? Not bad. Why? Because u prime was only off by a what? Constant. And what can we do with any constant if it's a, now careful, just a few of you, and I've seen this mistake over and over again in calculus, A, B, M, B, C, would pull out a 4. What did I pull out? A 1/4. Why? What's the understood number on top? 1. 4 is in the denominator. It's division, not multiplication. Division by 4 is 1/4. Okay, but anyway, if it's a constant, I can pull it out. If it's a constant, I can pull it out. What else could possibly, oh, that's the one we just did. Sad day. Ah! What else could possibly happen? As you guys are setting this up, there is a question over on the side. Thomas. If they don't match, it would be, another technique would be necessary. But for you guys, what Thomas asked was a great question. He's like, what if you have a secant and a tangent, but the insides don't match? Are you allowed to take like a secant u tangent v and go back to secant u? No. So we'd be in trouble. Let's just leave it there. We'd be in trouble. And I've never seen, actually on AB or BC, I've never seen one of those. If that was the case, we would probably need to go back to like the pre-cal huge pages of formulas to say, is there any way that I can make it match by using composite arguments, sum and difference rules, I don't know. Something. That's what I would be thinking, Tom, if I ever saw that. Well, it's a good question because, like, you know how I wrote the 4x cubed? That actually could happen, but the secant of, tangent of, that shouldn't happen. And if it did, we'd have to go back to pre-cal, and it would be a mess. Trying to rewrite the arguments, trying to rewrite the trig. Why does this page look a little scary? Yeah, maybe because it says crack. I don't know where it came from. One of the first years teaching, I don't know. Everyone was saying, like, you must be on crack. Like, it was just like a joke. I don't think people say it as much anymore. But I was like, is integration on crack? And they're like, oh. Anyway, it makes it memorable. The integration isn't specifically on crack. It's more like the substitution is. And what I mean by that is it's just crazy. Like, it's just weird, and it's out there. And it doesn't necessarily seem to fit the system, but it does. So let's see what happens. Part of it, one part of it is actually, it's going to be harder to choose your U. Because you kind of have to, like, look at it a different way. Not really. In some ways it's easy, but in some ways it's not. You guys have gotten used to, even when we were doing, like, chain rule with differentiation, right? F of u times u prime. And it's usually worse. And even in the integrals that we solved, if you guys check it out, anything with like square roots, it was the bigger polynomial that was being u, and the smaller polynomial hopefully went away. Even here, it was the bigger polynomial that we were choosing for u, the smaller polynomial. But question, where's the smaller polynomial in this one? Inside, which is a little weird. And that's actually an indicator that we're in trouble. Just a little bit, we'll be fine. But we have to think about this, to think outside the box. We have to kind of, I had a math professor in college that said math is better than drugs because he had totally, like, I don't know, and us all turned around and upside down and we were so confused and our brains had been, like, stretched. He was like, yeah. We're like, oh, man. Anyway. All of this allusions to the stupid name. And please don't ever put this on an AP or else we're all going to be in trouble. So, coming back. The U is still the inside. Even though it's weird, and even though some of you guys, like, once you get the process down really well, you're like, that doesn't make sense. I don't want the U to be a smaller polynomial because what's your du going to be? 1 dx. That doesn't help at all. If you understand the process, you're thinking it doesn't help at all. If you don't understand the process, you're like, I don't know, I'm along for the ride. Okay, hang in there. Hang in there. It's true, right? How do you solve for dx? That was exciting. What's our next step? Plug in. So we got to do it. But those of you thinking ahead, not just along for the ride, you're like, I don't get it. X squared, square root of u times du. Is this good? I would say it is good. But can we antiderive right now? Because you can only antiderive a function of u's with du's. And who's still here? He doesn't belong. So we just have to be creative. You see him? You see where else he is? Not only do I get to rewrite this guy to make it easier for myself to plug in, but I can also come back and rewrite this guy. Not only am I going to get u in terms of x's, but every now and then I need to get x in terms of u's because I'm like, I have too many x's. I won't make a joke. So then coming back. What can I do? Keep plugging. Keep substituting. Keep playing with it. You have to be just a little bit creative with this guy. And some of you are like, thanks and all, but I don't see how that made it any better. But why did it make all the difference? Back here, could I get the x squared underneath the square root? And make a nice little sum and difference of all these separate terms? No, it's illegal. Well, I guess you could technically make him, if you really want, the square root of x to the fourth, and then I could actually bring him in, and then I could make this into the square root of x to the fifth minus x to the fourth. I suppose I could do that, but that doesn't really help me either. So I actually could bring him in. It just wouldn't be very helpful. But what can I do here? What am I doing if I do u squared plus 2u plus 1? Foiling. Why would I possibly FOIL this expression? An impossible integral just became possible. Because now I can say this is u to the 2.5, which would be u to the 5 halves. I can say this is 2u to the 1.5, so that'd be plus 2u to the 3 halves, and then plus u to the 1 half. What was an impossible integral just became possible. What was an impossible integral just became possible. There was no way to do plus or minus with even the bringing in, like you guys saw me do it for a second. If I did bring him in, make him into a square root, and then distribute, there was no way to make that plus or minus. I can't get rid of that square root over everything. But down here, I can bring the square root in across pluses and minuses, and now I have a nice little sum and difference rule with power rules. So how do we anti-derive now? Anybody gotten 2/7 u to the 5/7? No. 2/7 u to the 7 halves? Patricia was looking out for me. Good. And then how about 2 times 2/5 u to the 5 halves? And then 2/3 u to the 3 halves? And then plus c? Pause. I'm just worried about a few of you. I saw it in pre-cal on a test recently. Can you do that? No! What's 2 times 2? Thank you. What's this 2 and over? Understood? 1, just in case. I'm only slightly worried about some of you. Who's you? Ugh. Does this look nasty? No. Do you see anything in common? Oh, yeah, he looks nicer. Do you see anything in common? I think I see a 2u to the 3 halves in common that I could pull out. Do you also remember that thing about, I don't know, a long time ago I said that the AP hates fractions with different denominators? Question. What would be a common denominator between 3 and 5 and 7? 1. That's the factor, the common factor, GCF is 1, but the least common multiple, like what can they all go into? 21? No. 70? No. 210? Oh, we can do better than that, though, can't we? Can't we do 21 times 5? What would 21 times 5 be? 105? 105. Why am I saying that? Because we could change all of these to be 105. So we would multiply this guy by 15, so that would be 30 over 105. We could multiply this guy by 21, so that would be 4 times 21 is 84 over 105. We could change this guy by multiplying by 35, so that'd be 70 over 105. We could technically pull out, what goes into all those? 30, 70, 84, 15, and 2. Oh, if you put them all together. Careful, though, they have different terms, so we can't combine them. But good idea if we could combine them. I think you can pull out a 2. So let's pull out a 2 over 105 times u to the 3 halves, and what's left? The 105's gone. 3 halves is gone. We have 15 u, take away 3 over 2, 4 over 2 is squared, plus, take away 2 from 84, and that's 42. The 105 is gone, 3 halves is gone, so that's u. And then take away 2, that's 35, and then he's all gone. Put the plus c on the outside. We don't want to, no. Oh, I multiplied 3 times 5 times 7. I just said forget it. Now, guys, if this was a multiple choice, I mean, obviously we're trying to make it match. Could you look at the answer choices, and if they look like that, stay there? Yeah. I'm just saying, what if they don't look at all like that? Well, they could have done some craziness. You guys said it was 1 minus x? No, x minus 1? To the 3 halves times 15, x minus 1 squared plus 42. I'm going to stop. But what could they do right now? Couldn't they FOIL it and then whoosh, into a nice little trinomial? They could. I'm not going to right this second. I'm going to go ahead and stop. But I'm just saying, if it looked like that, perfect. Plug in your x minus 1. You're done. The red before the green. But if it didn't look like that, they could have gotten common denominators, pulled out the 105, pulled out u to the 3 halves, and gotten this nice little polynomial that you could actually simplify if you wanted to pretty quickly. Warning, 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 make it match. We know it's a thing, right? Ready, set? I want you guys to try number 2, which is a little bit easier. Go. It's an x, not an x squared. But there's only one choice for you, even if you don't like it. What's the one choice for you? Go. I'm going to freeze the screen and turn it off so you guys can't see what I'm doing. Unless you just follow my pen, but life's too short. Try it. Lost my place. Show you step by step, piece by piece. Did the u, did the du, solve for my dx, plugged in for dx, plugged in for u. Came back, got him alone by time to plug and chug. Everybody agrees though, right? You haven't caught any mistakes? Okay. Here's another common mistake I see a lot. You get so focused on rewriting it, you're like, yay, and then you don't write the integral and you're like, I'm done, and you haven't anti-derived yet. Don't forget your antiderivatives. What am I going to have? A 1/4. I'm just going to leave the 1/4 out because he's in front of everybody anyway. So that'd be 2/5 u to the 5 halves plus 2/3 u to the 3 halves. I'm going to put plus c way over here because the 1/4 could be times a c1 and then be a c2. Basically, I can just kind of like multiply the c, sorry, by 1/4 and then just kind of move them off to be a new c. Would you guys understand if and a u to the 3 halves? What am I doing? Getting a comment? Why? because the AP doesn't like nasty fractions inside their parentheses. It's just a thing. So I'm pulling out the 15th, and I'm pulling out, well, there's a 2, and I'm pulling out the 15th, and I'm pulling out the 2. I'm going to end up with the 3's left over when I pull out all those guys, and I took away u to the 3 halves, so I just have a u left. Then the 5's left over, and I took away all his u's. Let's see, so I can make that 1/30th. U to the 3 halves, I'll get there, and then 3 times u plus 5. Who's my u again? I lost track. 2x minus 1? So let's throw in our 2x minus 1. Let's throw in our 2x minus... Okay, we can't just stop there. I was nice on the other one, but come on, we can do this one, right? Because this one's as basic as distribute. So I have 6x minus 3 plus 5 would be plus 2. Oh, I could pull out a 2. You're welcome. Let me go ahead and pull out a 2. So if I pull out a 2, that'd be 2 over 30. That'd be 1 over 15. I have my 2x minus 1 to the 3 halves. I pulled out a 2, so I have 3x plus 1 plus c. That would be the nice make it match multiple choice answer. That looks quite different, not only from the very beginning, but it also looks even quite different than that guy. Like, that doesn't look like, but oh, when you simplify, ends up being a lot nicer. If you guys want to grab a picture on the way out, you totally can. It'll be on the video. It'll be in your notes. We have one more day. This homework is due on Monday, but work on it tonight. See how far you can get. I bet you can get almost the whole way. Bye, guys. Please, please, please set yourself up for success. Start your homework tonight. Bye.